Hey there, geometry students. Welcome to the lesson for 10.2. You can find it on pages 603 to 611. Forgot what page that was there for a second. Alright, so central angle, major arc, minor arc, semicircle, more stuff about arcs, lots of stuff about arcs. Arcs and chords, that's what we're talking about here today. So we've talked about chords before a bit. Now we're going to talk about arcs. What are arcs? I think you have an idea of what an arc is before getting to geometry. And technically it's part of a circle. It sounds like the janitor is cleaning up outside too, so don't mind those strange noises you might hear. It's pretty loud. Okay, anyway, to start here, I want you to draw a circle, decent sized circle, $50 size, something like that. If you have some coins, again, I think that's a good idea when we're drawing circles in these notes to use something like that, or maybe I even had one of my students today tell me they used like a nail polish bottle. If you're a female, man, janitor, go away. We'll see if they're coming in. Can you hear that? I don't know. Can you hear that? I think that's probably loud enough where you can hear that on the video. But let's draw in the center of the circle, and I want you to draw in an angle centered in the circle. A central angle right there. It's in the center of the circle. And we're going to use some different colors at this point. So I want you to take this circle that you drew, and in a different color, I want you to kind of go over this part of the circle again. So I'm going to highlight this part of the circle. I'm going to use red for that. I'm going to go over that part of the circle. From there to there, this is called, in a different color, please be doing this in that different color, this is minor arc. And haven't given these points labels yet. I'm going to say this is point A, this is point B, this is P, and this is going to be C, just some point off on that part of the circle there. So minor arc, and we would label this as minor arc A, B, and you would also put this above that. And so minor arc, if you put the arc mark above it, this is actually sort of redundant to say minor arc AB, because this is essentially saying minor arc AB. So you're saying arc sort of twice there. We'll just be writing it once later on. So let's underline that. And I'll put a colon there, then it's not so redundant. Then I'm saying this is a minor arc, and this particular arc is called AB because you're going from A to B along the circle in that direction. Now, how do I know to go from A to B this way and not this way? Well, if you have an arc that's bigger than half the circle, bigger than a semicircle, you're definitely going to want to use 3 letters to designate that this way. If you're going to just use 2 letters, you connect them in the fastest way possible, or the shortest way possible. If you're going to use 3 letters, that will go the long way around if it's going from A through C to B. We would call this one, I'm going to use a second color for this. You don't have to use a second color. You can just make this darker if you don't have a second color. But if you do have a second color, that'd be even better. But if you want to just put this a little darker, a little thicker, in the same basic color you're using, that's fine too. But that's this bigger part. And if the littler part is called minor arc, you might have an idea of what this is called. If you say major arc, you got it. So this is major arc A, C, B. So let's put colon there. This is major arc, and you have this arc symbol above that still. It's almost a straight line, but it's got a little bit of a curve to it, a little bit of a bend to it. And this is major arc A, C, B. And then right here, the angle right here, let's make a little notation of that. That is a central angle. It's a central angle because it's in the center of the circle. So its vertex, not one of its vertices, but its vertex itself is right there in the center. You could call this angle P since that's the only one here, but I'm going to use 3 letters. You could say A, P, B, or BPA would also work. So that is that. This and this can be in the same color if you wanted to, but this minor arc I definitely want to see in that different color. And let's go to an example now at this point. Let's check out example 1. I want you to draw another circle about the same size as what you just did there. Another circle, Mr. Wagner circle. Where's your circle tool? There you go. Circle, circle. Hey there, hi circle. And let's find that center point. Mark that center point. And then I want you to draw a straight line going all the way across through the center. That would be a diameter. Looks like my pen, I didn't lift it, but it's doing that again. It's being funny. It's being silly. Let's try it one more time. Yep, still doing it. Let me try going in a different direction then. There we go. Okay. So diameter going all the way across there. I want to make one of these angles a little less than 90 and one a little bigger than 90. So that would be 90 right there. So a little less than that. I want to make it about 65. This I'm just approximating. So I'm going to say that's about 65. This one's going to be 115. And I don't want to go straight down from here. I want this one to be a little smaller yet. So this one I'm going to make about 30. I'm trying to just eyeball this as best I can. So I want you to write in here a few more things. This is 65 degrees. This is 115 degrees. This is 30 degrees. These are all central angles because they have a vertex. They have the vertex at the center of the circle. And let's call this C, U, R, and L. Aha, curling iron doing a bicep curl, playing the sport of, the Olympic sport of curling. All different things that curl could refer to. The measure, now, if we're going to say it's the measure of an angle, we put a little m in front of the angle. If we're going to say it's the measure of an arc, minor or major, we put a little m in front of the minor or major arc. So what if I asked you about these different things? So what's the measure of minor arc RL? What's the measure of arc LU? What's the measure of arc RUC? And what's the measure of LUC? What are all those measures? RL, if we look right here, that would be the short way. The minor arc way is the short way. So connecting R to L in the fastest way possible. It's going to be the same as the measure of the central angle that matches up with it. So central angle, the arc measures, they match up. They're exactly the same. Therefore, this would be 30 degrees. LU, now is that going to go this way around or are you going to go this way around? Remember, if it's got two letters, that's the short way. Okay, remember that. That's the short way. The shortest way possible, if it just has two letters, from L to U would be going this way. So you'd be taking 30 plus 115. That's going to be the whole thing there. 30 plus 115 is 145 degrees. So this is the final answer there. This is the work to get to that answer there. And now RUC. RUC. So that means if it's listing three letters, you have to go from the first letter and then connect it to the third letter through the second letter. So you have to go through the second letter, R to U, and then to C. And so with this one, it happens to be half of a circle. It happens to be just 115 plus 65. 115 plus 65 is just 180. So we have 180 degrees here. That is something called a semicircle. We're going to make some notes off to the side with these after we finish figuring all the values out. And now LUC. What way would I be going there? I would not be going from here to C this way, because that would be the short way. That would just be the measure of LC. And I want to add that one to here. I wasn't originally going to do that one, but let's say I had that instead. So the measure of LUC would be 30 plus 115 plus 65, because I'm going from L through U to C. And so we have 30 plus 115 plus 65. This would be 145 plus 65, which is 210 degrees. And now if I think of this, the measure of LC, That's going from L to C the short way. So notice the difference here. The shorter way, 2 letters. The longer way, 3 letters. Now if I had another point right here and I called it, let's do this too. I'm going to add another point in here. So curl, I'll make it an I. This would be the same thing in this case as the measure of LIC. So sometimes you might see a minor arc actually has 3 letters. That's not very common, but if it says LIC, you start at L, go through that second point, go through I, and go to C. So in this case, it happens to be the same as that. Now this would be the same as the measure of, you could take 360, so let me erase that actually. Sometimes it's easier to think of it this way. So this one you would take 360, which is what you get when you add up everything in a circle. Be 360 minus the one we already figured out, LUC. What would be left over if you went from L to U to C? The rest of the circle would be this part, the LC part or the LIC part. And so you'd have this is the same as 360 minus LUC, that arc. And so this was, we just figured that out right up here. 210, that's right there. So minus 210, which would equal 150 degrees. And before we move on, I want to make some different notes here in a different color. So I want you to circle or to make a little note like this. Let's just do it like that. These ones. So these two, these are major arcs and semicircles. And when we're doing those, we're going to always use 3 letters. And I could have worded this a little better, I think, but always use 3 letters, and they are greater than or equal to 180 degrees. So that's something we need to know about major arcs and semicircles. These two, these are examples of minor arcs. So I'm running out of space here. I'm going to do this over here. So minor arcs. You'll generally use 2 letters. But in this case, like I had it here, just because it has 3 letters, don't assume that it's a major arc. You have to look at the picture and go from L through that point to the other point. So generally use 2 letters. I'll put generally, I'll underline that. So major arcs generally use 2 letters, and they are less than 180 degrees. Not less than or equal to. Equal to is a semicircle. Okay, that should do it for example 1. I want to point out a couple things in the book with the next things we're going to write down. We're going to have a couple things here about congruent arcs. And theorems 10.4 to 10.6. I'm not going to have you write all this stuff out. I do want you to have this on your notes though as reminders. I want you to see example 3, page 604. I think it's pretty easy just to look at that together a moment with you. And then these theorems, page 605, that's where you can find those. And they deal with midpoints. Oops, midpoints of arcs. So let's bring that up here. So example 3, here we are. Just want to look at this with you together. Notice if they have the same degree measure, 45, 45 is essential angles, that means the arcs are going to have that same degree measure. But they also have to be the same size. So they have to have the same size as well. So this triangle, these are both radii, or these are all radii here, and so that would have the same size of that because it's the same distance away here and here. meaning those would have to be congruent. Notice if you have two separate circles, these ones, same degree measure, but we would have to know that the radii are the same. Here we know that the radii are the same, so that means this arc PQ would be congruent to this one. But notice in this one you've got two arcs. Yes, the central angle is the same, but clearly this is not congruent to this because this second circle is much larger than this first circle. So these would not have the same measurement. If you put one arc here, you put that one right on top of this one, they would not match up exactly. Okay, so they have to match up exactly, same size and shape if they're going to be congruent. I want to look at theorems 10.4 and 10 through 10.6 briefly with you a moment here too. So we're going to be using some of these in context. If you want to write these down on your own time, you're welcome to do that. But I'm just going to point you to them here. So let's see what they say right now. I think once you read them, you should be able to understand them pretty easily. So in the same circle or in two congruent circles, any congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So this chord AB and this chord BC, if they're the same, that means arc AB, minor arc in this case, is the same as minor arc BC from here to here along the circle. Theorem 10.5 says that if you have a diameter that's perpendicular to a chord, so just like here, this is the diameter right here, chord is the FD right there, then the diameter bisects the chord. So you could actually put a little mark right here and a little mark right here. And this one, if chord is perpendicular bisector of another, and the first chord is the diameter. So this is the converse, the reverse of this one. So if it is perpendicular here and this is the same as this, that means JK has to be a diameter of the circle. So we're going to use those theorems in the context of some examples together, or at least one of those theorems in the context of an example together here. I want you to draw a circle for this one. Wow, imagine that. Circle chapter. I'm going to draw a circle. Okay. Enough of me being sarcastic. Let's get into the problem. And let's draw the center point of the circle. Locate that as best you can. And I want you to draw in something like that. It'll look kind of like a peace sign. And then we're going to connect these here and here. So there's a chord, and there's another chord. You connected 2 points on the circle. So it kind of looks like the Acura symbol for cars. It's almost like that. And I want you to put this being the same as this. And if you ever see something written like this next to the circle, they're saying the measure of that arc that it's centered on. So the measure of this arc from B, I'm going to call this B, I'm going to call this C, and D right here. And that's going to be A. So this is 2x plus 48 degrees. That's the measure of this arc, BC. And this one over here is 3x plus 11 degrees. And so if I go back to the theorems I was just looking at, it looks like this one. So if I have chords that are congruent, that means their arcs are going to match up. You can also say if the arcs match up, that the chords are congruent. It's an if and only if statement. So that works both ways. So based on or using theorem 10.4 for this one, what can we say? We can say that the measure of BC, of arc BC, is the same as the measure of arc BD. Meaning, I can set this expression equal to this expression right there. So meaning 2x plus 48, that's what the measure of BC is. That's going to equal 3x plus 11. And now it's an algebra problem. So now I'm going to subtract 2x, it looks like would be the easiest way to go about it. Subtract 11. Work that out. This will cancel here and here. This will cancel here and here. I'm left with 37 equals just a single x. So 37 is x. Now let's suppose I asked you to figure out the measure of arc BC after that. So let's assume that I asked you for that. What would you do? You would plug it back in. So here's BC. Take 2 times 37 plus 48. That's where that number is coming from right there, from the x. This is going to be 74 plus 48. This should equal 122. And to verify your answer beyond that, you could actually plug in 37 into the other one, see if that worked out as well. And so you would do that, you would get, this would be 3 times 37, that would be 111, and then 11 plus 111 would be 122 as well. So that would work out either way you look at it. Okay, let's move on to looking at Theorem 10.7, and then we'll look at our final example, example 3. So Theorem 10.7, to save ourselves a little bit of time in the notes here, I'm going to make this as concise as I can. It says that if two chords are congruent, and you can see more about this, write this down for me, you can see more on page 606 for this. We're going to look at that in just a moment. This is an if and only if statement, so it works in both directions. Let's look at what it has in the book here. So Theorem 10.7, if and only if EG is congruent to, or EF is congruent to EG. So what's that saying here? Two chords are congruent if and only if they're equidistant from the center. It's saying that AB, this chord from here to here, is going to be congruent to chord CD if and only if this one, EF, and this one, EG, are congruent to one another. So equidistant, the same distance away from the center of the circle. So if this is the same as this, remember when we find the distance between a point and a line, or a point and a segment, we have to take the perpendicular measurement. So perpendicular here, if this is the same as this, that means this is the same as this, and vice versa. Let's write the rest of that down here. Two chords congruent implies in both directions, if and only if statement, chords are equidistant from the center. And so to finish this up, here's our final example. Draw another circle for me, about the same size as those other ones, not too big, not too small. Find the center points, and we're going to draw in a number of different segments in here. So I want you to try to make this look symmetrical as best you can. I want you to draw something like that, and then try to make it look exactly the same on the other side. So something like that. That looks pretty close, looks pretty good there. Connect that point to the center, and connect that point to the center, so keeping that symmetry. So it kind of looks like a W right now. Mine's not absolutely perfect, but it's pretty good, pretty close there. You're trying to do the best you can with what you got here. I want you to draw in not both of those. I actually meant to, hopefully you're doing this in pencil, I meant to not put that one in there. Sorry about that. And let's write in, oops, there we go. Let's write in some points for these letters. So that's going to be A, F, D here, that's C, this is E, G, and B. And just a couple more things here, some tick marks. So that's congruent to that one, and this one is congruent to this one. So based on that, let's say I gave you this information. Let's see if we could find what I'm asking you for. So AD, let's say, is 40, and CD is 25. And I'm going to say find CG. What is the measurement from C to G? Okay, so we got a lot of information here in the picture. We've got some extra information given to us here. I want to draw some things here now on the picture. If AD is 40 from here to here, let's put that in like this. Use a different color now to label some extra things on the picture. If AD is 40, what is it going to be from here to here? Well, clearly, I hope that's clear, that you would be taking that and dividing it by 2, because you have two congruent segments, one there, one there. So that would be 20. and so would that. That would be 20 as well. And CD, these are all the same, so it says congruent, 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 they're all congruent. This would be 20, and this would be another 20, so they're all going to be 20. CD, it says, is 25. And now, look here, you've got this chord would be congruent to this chord. They're both 40. They're both 20 plus 20. They're both 40. They're both 40. And if two chords are congruent, AD here is congruent to BE, two chords are congruent, that means the chords are equidistant from the center. Meaning we could also add this in the picture in a different color. Let's do this. We could say that that is the same distance as that. Equidistant meaning that this would have to be perpendicular to this as well. We could also say that. I know the way I drew it doesn't look exactly like that. It wasn't a perfect picture though. So we can focus on this part of the triangle, and I'm going to redraw that part of the triangle. So I'll put this, kind of circle this part here in a different color. We're going to redraw that down here a little bit bigger. So this is going to be, let's keep our different color for that. That is not quite what I wanted there. That's a little better. Okay, that's a right angle right there. This is F, this is C, and this is D. Okay, so I just expanded that picture a little bit. What I had up here, FD and C, this is 25 and this is 20 in that picture. How can I solve for that side right there, for CF? Hopefully you're screaming at me right now, Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. And if you're saying that, if you're not screaming it, man, gotta get motivated here. We gotta get excited about math. Woo! Yeah. Yes, I know. I'm weird. I don't care. I like math. There's no getting around it. I like math. I really enjoy math. So I've got CF. I'm going to call it CF. You could call it X if you wanted to later. But we're going to go with CF here. So I wanted to say one thing before I get into this too far. Why could I say that I was perpendicular again? So Theorem 10.7, which we just talked about up there, that was saying, that's implying that since, oh no, I don't want to write since. That is showing us that because the chords were congruent here and here, we have CF is equal to CG. So right here is equal to that. You can also say that CF is perpendicular, segment CF is perpendicular to segment AD. And you can also say that segment CG is perpendicular to segment BE. So now we'll get into what I was saying here. So let's make a little note there. By the Pythagorean theorem, we can say that 20 squared plus a leg squared plus leg squared, CF squared, equals hypotenuse squared, equals 25 squared. Now we're just solving for CF here. This would be 400. This would be still CF squared. This would be 625 if you subtract 400 from both sides. That would leave you with CF squared equals 225. You take the square root of both sides, and you have CF. This would cancel out with the square root. CF equals 15. And what is CF also equal to? CF here equals CG. And I'm trying to find CG. I know they're congruent based on Theorem 10.7. So I can say that would equal, not G, I guess it would be the same thing as GC, but I'm going to write it the way I had there originally, CG. So let's make one final little arrow here, whoops, from here down to here. That's why I could say CF equals CG. That's why I could say 15 also equals CG based on that fact. And so I've done what I needed to there. There are quite a new batch. There's quite a few new theorems here in this lesson. So go back to the book, review those things. I tried to make sense through examples of the most difficult ones, in my opinion, and then the other ones I tried to show you some examples here in the book. But check out those extra examples in the book as well to verify those things and make sure you got those down. If you have any questions beyond that, let me know in class, and I will see you guys later.